This movie will take you through the spin casting of an 8.4 meter honeycomb mirror. This mirror is one of the 7 segments of the 25 meter primary mirror for the Giant Magellan Telescope. Spin casting starts with building a mold that's the negative of the honeycomb structure. After the mold is built, glass is loaded onto it, the mold is enclosed in an electric furnace, and the glass is melted. While the glass is molten, the mold spins to give the top of the mirror the parabolic curvature that we want. The first part of the movie is a sequence of photos taken 1 per day during the mold construction and casting of GMT Segment 2. The mold includes a hard tub made out of silicon carbide cement. We build it on the turntable of a spinning furnace. We first lay down the floor of the tub, then add the walls. It's built like a barrel with staves that are wrapped with steel bands to hold it together. These materials will change their dimensions when they go through the heating cycle. So we install the furnace in pieces and do a preheat to stabilize the dimensions. We do a test spin of the furnace at the same time. Next, we line the tub with ceramic fiber and install 1,700 hexagonal boxes of the same ceramic fiber. When the glass melts around the boxes, it will create the cavities in the honeycomb. The ceramic fiber is much softer than the glass and doesn't have any chemical interaction with the glass, so it's easy to remove the ceramic fiber after the mirror is cast. Again, we heat the mold in order to stabilize the dimensions before adding the glass. The glass is O'Hara E6 borosilicate, delivered to us as irregular blocks. Each block was broken out of a larger piece, so the surfaces are pristine and the blocks melt together without any trace of the original blocks. When the glass loading is complete, we reinstall the furnace and raise the temperature to about 1200 degrees C, spinning the furnace as the glass starts to melt. Now we'll change to a view from one of the cameras mounted in the ceiling of the furnace so we can watch the glass melt. It reaches a thickness like cold honey and takes a few hours to flow down the 12 millimeter gaps between the hexagonal boxes. As the glass melts, it becomes transparent and you can see the hexagonal boxes. You can also see some bubbles of trapped air rising to the top and bursting. Here's a close-up view of the side of the mold from a different camera. The side is marked with the height in inches above the tops of the boxes. We want to finish with a glass thickness of about 2 inches, and that's where the glass surface stabilizes after it fills the mold. Once the liquid glass is stabilized, we cool it quickly to solidify, then cool it slowly down to room temperature. Most of the cooling is the process known as annealing, when the atoms in the glass get locked into place forever. Temperature variations need to be very small during annealing, and we achieve that by cooling at a rate of 3 degrees C per day. The whole cooling process takes 3 months. At the end of that time, we can open the lid, remove the rest of the furnace, remove the silicon carbide tub wall, and we're left with a cast honeycomb mirror. It still has a ceramic fiber trapped inside, and it's still attached to the silicon carbide floor tiles. These will be removed in the next step. In order to remove the mold material, we need to lift the mirror off the turntable and move it into a turning fixture. We use a steel lifting fixture bonded to the top of the mirror with compliant adhesive and with the load distributed to minimize stress on the glass. Now we'll switch to a different view. It's actually a different mirror, GMT Segment 3, but the process is the same. We'll lift the mirror and move it to the turning fixture. We'll use the turning fixture to raise the mirror into a vertical plane, giving access to the bottom surface. This transfer takes about a day, so we'll speed it up. Now we'll install the mirror in the turning fixture and lift it up. We'll bring in an enclosure to protect the mirror and contain the mold materials as they're removed. The enclosure holds an elevator platform, so the technicians will have access to all of the rear surface. They first remove the silicon carbide floor of the tub, then they'll wash the trapped ceramic fiber out of the mirror with high-pressure water. This completes the casting process. We have a light-weighted honeycomb mirror that is 80% hollow.